I'm Anna Mackay, and in this video we're going to look at solving exponential equations using logarithms. Starting off with this example here. So when you see the x in the power and you go, how am I going to remove it from there? You apply a log to both sides. So we start by writing log of 2x is equal to log of 30. And then there's the rule about bringing x down out of the power. Just a refresher on that law here. You probably have seen it before written like this. So if the unknown is up in the power there, you bring it down out the front and leave everything else the same. So on this next line here, we're going to do just that. Everything else stays the same. And now x is being multiplied by this log 2 thing. Well, log 2 is actually just a number. So when x is being multiplied by a number, we can do the reverse, the opposite, inverse operation of that. And we're going to divide both sides by log 2. So I'm going to write on the right hand side log 30 divided by log 2, and that's our final answer. Just a reminder that this is not equal to log of 30 over 2. You can't remove the log like that and make it one log. That's a different law. So the second part of this question was to find the answer to 2 decimal places. So part A was solving it exactly. We've done that using our calculator now. So you get your calculators handy if you don't already have them. Type in log 2 and enter. Here's one I've prepared earlier, so to speak, and your calculator will have a similar view window to something like this. Now it said 2 decimal places, so remembering we always have to look at the third decimal in that place. It's a 6, so it's going to round up, so that 0 becomes a 1, and so our approximate solution is 4.91. You can do sort of the wavy equals, or sometimes another option is equals with a dot top and bottom. Now, using some natural logarithms, so if you haven't been doing work on these, perhaps pause here and ignore this section. So finding x exactly. Again, we have x up in the power, so when that happens, you apply a log to both sides. But when you see an e, you don't write a log. You could, but we apply a natural log, and the abbreviation for that is ln. So I'm just going to do it long ways first time round to show you or refresh your memory if you need it. So if we apply a natural log to both sides, that's what this would look like. And then we would bring x down out of the power, just as we've talked on the previous example. Now, a refresher, the ln, perhaps I'll just write that over here. What's that equal to? It's equal to 1. So that means x is being multiplied by 1, so the answer for this is just ln 30. And it's absolutely fine to go straight from the question to this answer here as you become more familiar with using logs. Second part here, so 3 multiplied by e to the power of x on 2. So we have to isolate x on its own. So first of all, you want to detach that 3. So we're going to divide both sides by 3 to get 7 on the right hand side. Now again, bringing x down out of the power. To do that, you apply a log. Because it's got an e, we're going to use a natural log. So we're going to go to ln, but let's go straight to using the rule. So we can see the power there, x on 3. Let's just write it straight without the ln on the left hand side. So we're going to write x on 3 and have the ln on the right hand side. That's how I do my l's, because otherwise sometimes they look like a 1. And then keep rearranging. So we're going to multiply through by 3 and we're left with ln 3, ln 7, and that's our exact answer. Our next video in this series is 13F on growth and decay.